Next up, we're going to take a look at solving quadratic equations. So first, let's understand what a quadratic equation is, right? So what is a quadratic equation? So it's got two words in it, and so we know the second one, equation, means it's got an equal sign, and we solve these kinds of things. We talked about this at the beginning. And what is a quadratic? A quadratic is an equation that looks like this. Oh dear, we've seen that before, haven't we? And what is it equal to? Equal to 0. So that's a quadratic equation. So for example, it'll be nice if we could solve quadratics that look like this: x squared plus 5x minus 24 equal to 0. Or 9x squared equals 27x. So what makes something a quadratic is the fact that the degree of the polynomial, another new old word, degree is 2, right? So the highest degree of the polynomial is 2, degree 2. Degree polynomial is equal to 2, and we have one variable as far as we are concerned in this class. All right. So to solve a quadratic equation, you need a property, and this property is called the zero factor property. And these words also are important. Zero, right? Factor property. Okay, so it's got to be 0 in there, it's got to be factors in there, and this property says the following. It says that if m times n, now these are symbolic for two things that are multiplying each other, is equal to 0. If m times n is equal to 0, then we can conclude 1, m is equal to 0. This can happen if m is equal to 0, or 2, if n is equal to 0. Now it is important that it be 0, not 1, not 2, and so on and so forth. So if m times n is equal to 0, then this is the conclusion we can come to. Now how does this help us solve equations? So solve example 1. Let's say you had x plus 8 times x plus 2 equal to 0. Now you can clearly see, I hope, that this is like m times n right there, equal to 0. So it matches the if part of our property. Now solve, of course, means, so solve means that you want to find x. Okay, that you want to find x. So we can see if this property would help us achieve that. So let's say we have x plus 8 equal to 0 by our property. That's the first conclusion. And the second conclusion is that x plus 2 is equal to 0. You can see then how easy it is to solve for x by simply subtracting 8 and getting x equals to negative 8, and subtracting 2 and getting x equals to negative 2. So that is the answer. Sometimes you may see the answer written like this using set notation. Either one is correct and acceptable. So let's do another one and use the zero factor property. And this time we'll say we have to solve 2x plus 5 times 3x minus 7 equal to 0. So this time we have 2x plus 5 equals to 0, or from the zero factor property, 3x minus 7 equals to 0. And so you can solve each of these on their own and get yourself your answer. X equals negative 5 halves plus 7 to both sides. 3x is equal to 7 divided by 3 and x is equal to 7/3. Alright, so how does this idea help me solve a quadratic equation? So this time let's look at a quadratic equation. Solve x squared plus 5x minus 24 equals to 0. To solve a quadratic, well, if we could get it to look like this up here, then we can actually solve this. Well, we know how to make it look like that. If we were to factor, then we can get our two factors. So this is one of those trinomials that is easy to factor. We ask ourselves what numbers multiply to be negative 24 while adding to be 5. So that would be x plus 8 and x minus 3. And now we have our two factors, our m and our n. So we can say 1 x plus 8 equals 0, 2 x minus 3 equals to 0, and then subtract an 8 over and say x is equal to minus 8, or x is equal to 3, and report our answers. Let's do another one. So this time let's solve this one. 9x squared equals to 27x. Now, key to solving quadratics is to make sure first, one, you want to make sure you have it set equal to 0. Make sure to set equal to 0. And if it's not, then it's a matter of subtracting 27 over and getting yourself like so. So how do you factor this? Well, think back to two terms. Is it the difference of two perfect squares? Well, on the left, yes, but on the right, no. So it's not that. Well, what else techniques do we have to factor? Ooh, GCF. Okay, so 9 over here, 9 over there, that's 9 times 3, and x to the first power here, so lowest power is x, so 9x is a factor, g's greatest common factor, and that leaves me with x minus 3. Now, is this in the form of m times n equal to 0? Well, it is if you think of that as m and you think of this as n. So you can draw the conclusion, 1, that 9x is equal to 0, or x minus 3 is equal to 0. And then solve each of these individually. So dividing through by 9, you get x equals 0, adding a 3 to both sides, and you get x equals 3. Let's do another one just to make sure that we understand this. 4, where is that, 4 or 5? No, 4 it says. Okay, so solve. And this time let's solve something that is the difference of two perfect squares. So what if we had z squared equals 144? So again, you recognize a quadratic, right? Recognize quadratic, and you want to set it equal to 0. So I'm going to subtract 144, and I get z squared minus 144 equal to 0. So now, is this the difference of two perfect squares? Well, here I have z times z, there I have 12 times 12, so my a is z, my b is 12, so indeed this is the difference of two perfect squares. So I can write this as z minus 12, z plus 12 equals to 0. And now I have my mn pattern. And so I can do 1 z minus 12 equals to 0, or 2 z plus 12 equals to 0, and then add 12 over here. I get z equals 12, and subtract 12 over there and get z equals negative 12. And that's it. That's how you solve a quadratic. I'd like to do one more example in this series of solving a quadratic to complete out the problem in this one here. So let's say we had to solve x minus 5 times x plus 2 equal to 8. So you, first of all, it's hard to see that this is a quadratic because it's not multiplied out. Second of all, but of course you can sort of see it, right? Because you know that if you would multiply those two, you're going to get an x squared. The second thing is that's not equal to 0. So if imagine we move the 8 over. Well, the problem now is that this is not a quadratic. So to get it to look like a quadratic, we have to distribute. So let's go ahead and do that. So that's x squared, 2x minus 5x minus 10 minus 8 equals to 0. So combine our like terms, x squared minus 3x minus 18 equal to 0. So now we can factor this to see if you can get it into mn form. So what numbers multiply to be 18 while adding to be 3, negative 18 while adding to be negative 3? So that would be negative 6 and positive 3. So x minus 6 then would be 0, or 2x plus 3 could be 0. So add 6 and you get x equals 6 minus 3 and you get x equals minus 3. And so these are your answers. That's it for solving a quadratic equation.